Welcome to qnawire.
Now we need, we're going to choose plus y to be downwards, because if we choose it to be downwards for at least part A, it becomes a lot easier to evaluate. We can say that here delta y is equaling Vy initial for the rock or the boulder plus 1/2 accelerated y direction times t squared. The boulder falls horizontally, so we know that the initial y velocity of the boulder is 0, and we can say that t would simply be equal to the square root of 2 times delta y divided by the acceleration in the y direction. This would be equal to the square root of 2 times 20 meters divided by 9.80 meters per second. Now, this is going to be equal to 2.02 seconds. However, the must travel 100 meters during this time in order to clear it. So we can say that the initial x velocity should be equal to the change in the x and change in the displacement in the x direction divided by t. This is the definition of velocity. We have no acceleration in the x direction when an object is in free fall. This would be equal to 100 meters. This would be divided by 2.02 seconds, and we have that the initial x velocity of the boulder must be equal to at least 49.5 meters per second. This would be your answer for part A. Now, for part B, we are going to say that now we have the question is, how far from the foot of the dam does the rock hit the plane? So we can say that here the change in y displacement here is 45 meters now, and so the time would be equal to, again, 2 times delta y divided by the acceleration in the y direction. We, again, still have no initial velocity in the x direction, so we can use that same relationship. This would be equal to 2 times 45 meters. This would be divided by 9.8 meters per second squared, and this is equaling 3.03 seconds. And so it's asking us where does it land. We say that delta x is equaling v x initial times t. This would be 49.5 meters per second multiplied by 3.03 seconds. This is equaling 150 meters approximately. So the rock lands, we can say 150 meters minus 100 meters. This equals 50 meters beyond the foot of the dam. This would be our final answer to part B. That is the end of the solution. Thank you for